Hello everyone, I am Dr. Tushar Chaudhary from Indian Institute of Information Technology, Design and Manufacturing, Jabalpur. I welcome you all for the first lecture session on fuel cell technology. It is an exciting course where we are going to learn about the emerging technology in renewable energy sources, where we explore one of the most promising and sustainable means of energy conversion, that is fuel cell. Fuel cell are the forefront of the clean energy innovation, offering immense potential to reshape our world. Throughout this course, we will develop into the fundamental application and remarkable possibility that fuel cell technology bring to our ever evolving energy landscape. By the end of this session, you will able to learn about how to explain the fuel cell, explain how the fuel cell work and what principle are involved in this. Also able to identify the types of fuel cell and its component in different application. Fuel cell is an electrochemical device that converts the chemical energy of a fuel into electrical energy through an electrochemical reaction of hydrogen containing fuel and with oxygen or another oxidizing agent. From this figure, we can see that generalized structure of a fuel cell. When fuel and air are allowed to pass through this channel, they react, and when they come in contact together across the porous membrane, that is electrolytes, which separates them, this reaction results in transfer of electrons and ion across the electrolyte from the anode to the cathode. If an external load is attached to this arrangement, a complete circuit is formed and a voltage is being generated from the flow of this electrical current. The voltage generated by this single cell is typically rather small, that is less than 1 volt. So, many cells are connected in series to create a useful voltage. Here the fuel cell have different components. From the figure we can see the essential components of the fuel cell. The first component, we are going to have the electrode. It is in a thin catalyst layer pressed between the ionomer membrane and a porous electrical conductive substrate. Second, we have the electrolyte. It is in a chemical compound that conducts ion from one electrode to the another side of the fuel cell. Third, we have the catalyst. It is a substrate that cause or speed up the chemical reaction without itself being affected. Fourth, we have the bipolar plates. It is a conducting on the anode of one side to the cathode to the adjacent side. Lastly, we have the gas diffusion layer. This layer is between the catalyst layer and a bipolar plate, also called electrode substrate or a diffuser or a current collector. The combined assembly of anode, electrolyte and cathode, we called it as an membrane electrode assembly. In short, we call MEA. From this figure, we can see the relationship between the electrolysis and a fuel cell. The water electrolysis and fuel cell are closely related electrochemical process that involves the manipulation of water and its component, hydrogen and oxygen, to produce either electricity in case of fuel cell or a hydrogen or oxygen gases in case of water electrolysis. Here an overview of each process we have. Water electrolysis, it is a process that splits water into its constituents element, that is hydrogen and oxygen, using electrical current. It is essential that reverse of this chemical reaction that occurs in a fuel cell. The key component of water electrolysis, we have first the electrolyzer. It is a device used for water electrolysis, we call electrolyzer. It is typically consist of an two electrode, anode and cathode, separated by an electrolyte, usually an aqueous solution of an alkaline substance or a solid polymer electrolyte in case of PEM electrolyzer. Second, we have the anode. At the anode, water molecule loses electrons and are oxidized to form oxygen gas and positively charged hydrogen ion. Third, at the cathode hydrogen ion electrons are reduced to form hydrogen gases. Fourth, electrical energy. An external power source such as a DC power supply provides the essential electrical energy to drive the electrolysis process. The electrical current flows through this water, causing the reaction at the anode and the cathode. Fifth, we have the hydrogen and oxygen generation. The hydrogen gases is generated at the cathode, while the oxygen gas is generated at the anode. These gases are collected and used for various applications such as fuel for fuel cell or industrial purposes. In fuel cell as explained in previous response are a device that use hydrogen and oxygen to produce electricity through an electrochemical reaction. The key component of fuel cell include anode, cathode and electrolyte. Similarly to an electrolyzer, however, in a fuel cell the primary purpose is to generate electricity rather than produce hydrogen and oxygen. The key difference between the water electrolysis and fuel cell we have: first, that is purpose. The water electrolysis is used to produce hydrogen and oxygen gas, whereas fuel cell use hydrogen and oxygen to generate electricity. Second, direction of reaction. The water electrolysis is the forward reaction, splits water into its component, while fuel cell operates in a reverse direction, combining hydrogen and oxygen to produce electricity. Third, we have electric energy input. In water electrolysis, electrical energy is supplied to drive the process. In fuel cell, the energy is produced as a result of electrochemical reaction. Fourth, that is application. Water electrolysis is primarily used to generate hydrogen for various applications including fuel cell, vehicle, industrial purpose. Fuel cell on the other hand are used to convert hydrogen and oxygen into electricity for powering wide range of devices and system. Both water electrolysis and fuel cell plays an important role in emerging hydrogen economy, with water electrolysis being a key method for producing hydrogen for fuel cell application, which can be particularly important in clean energy and transportation sector. The categorization of electrochemical devices is seen here from this tabulation. Here the electrochemical device is separates in two devices. First we have the battery and second we have the cell. The battery is further divided into two subtypes based on rechargeability. Primary batteries, also called non-rechargeable battery. These are the single use battery that cannot be recharged. Alkaline batteries fall under this category. Secondary battery, that is we call rechargeable battery. This battery can be recharged and used multiple times. Example, lithium ion battery, nickel metal hydride and lead acid battery, whereas in cell is further subdivided into four categories based on the applicability. First, here the dry cell characteristics. Dry cell are compact and portable electrochemical cell that use a paste or a gel like electrode rather than liquid one. They have seal design to prevent leakage. For example, common dry cell battery includes zinc carbon battery and alkaline battery. They are used in various consumer electronics such as flashlight, remote control and portable device. Second, we have wet cell. The wet cell characteristics are: wet cell are, the name itself suggests, they use a liquid electrolyte. They are often larger and heavier than dry cell and are commonly found in application like automotive batteries. For example, lead acid battery are used in automobiles are classic example of wet cells. They have a liquid sulfuric acid electrolyte. Third, we have reserve cell, that is we also called mercury cell. Its characteristic is reserve cell are a type of dry cell that use a small quantity of mercury in the electrolyte. They are known for their long shelf life and stable voltage output. The use of this battery are in the application require consistent voltage over a extended period, such as hearing aids, camera, memory, power backup in electronic devices. Fourth, we have the fuel cell. Its characteristics are: fuel cell are electrochemical device that converts chemical energy of a fuel and oxidizing agent directly into electricity, heat and water through going on electrochemical process. Its applications are used in various transportation sector, stationary power generation and portable power sources. They offer high energy efficiency and low emissions. These different types of cells have unique characteristics and applications. Dry cells are popular for their portability and are commonly used in consumer electronics. Wet cells are large and more suitable for the application where size and weight are not constrained. Reserve cell are specialized dry cell with a stable voltage output. Fuel cell represents a stable and efficient technology for electricity generation, often used in environmental friendly application like hydrogen power vehicle and clean energy generation. Generally, the students have confusion regarding the basic difference between the fuel cell and the battery. The fuel cell are different from battery. Fuel cell requires continuous source of fuel and oxygen to sustain the chemical reaction, whereas in the battery chemical energy comes from the chemical already present within the battery. Fuel cell current produces electricity continuously as long as fuel and oxygen are supplied. The energy conversion comparison between the conventional and the electrochemical conversion is seen over here. In conventional energy conversion, the chemical energy of a fuel is converted into electrical energy via three different stages. First stage, where the chemical energy of a fuel is produced or processed in a combustion chamber, where the burning of fuel takes place and release heat. This heat is being used by heat engine through an mechanical energy to produce through an mechanical action. The mechanical action is being coupled with an generator, which electrical energy is being produced. In case of electrochemical energy conversion, fuel cell directly converts the chemical energy of a fuel into electrical energy. The basic principle of fuel cell can be understood from this figure. The fuel cell is based on an electrochemical process that converts chemical energy of a fuel and oxidizing agent directly into electrical energy, heat and water. Here the detailed explanation how the fuel cell works is described over here. First, the anode, which is negative electrode. Hydrogen gas is supplied to the cathode. At the cathode, hydrogen molecule is split into proton, that is H plus, and electrons negative. This process is known as oxidation. Anode reaction has been shown over here, where 2H2 gets 4 hydrogen ion and 4 electron. Second, we have the electrolyte. An electrolyte typically a proton conducting material, such as a solid polymer electrolyte in proton exchange membrane, or a PEM cell, or a ceramic material in solid oxide fuel cell. Separates the anode and cathode. The electrolyte allows the passage of proton, which blocking the flow of electron. Third, the cathode, which is positive electrode. Oxygen or air is supplied to the cathode. At the cathode, oxygen molecule combines with proton and electron to form the anode to the form of water. This process is called reduction. Cathode reaction we have, where half O2 plus 2 hydrogen ion and 2 electron results to form water. Fourth, we have the electron flow. Electrons released at the anode cannot pass through an electrolyte. Instead, they are forced to travel through an electrical circuit to reach the cathode. This flow of electron through an external circuit generates an electrical current which can be used to power device or system. Fifth, we have electricity generation. The flow of electron through external circuit generates electrical power that can be used for various applications, from small electronic devices to vehicle and stationary power generation. Sixth, we have heat generation. Along with electricity, fuel cell also produces heat as a byproduct of the electrochemical reaction. This heat can be harnessed for various purposes, such as heating water to provide climate control in vehicle or building. From this table, the classification of fuel cell is generally being done on the basis of various properties such as type of catalyst, membrane or electrolyte, operating temperature, anode material, species transfer, fuel to be supplied at the cathode side, fuel handling capacity, power range, advantage, disadvantage, application, and lastly on the basis of efficiency. So, first we have proton exchange membrane, that is PMFC. This fuel cell use a solid polymer electrolyte membrane typically made of nephron. They operates at a relatively low temperature, 60 to 100 degree centigrade, and are commonly used in a vehicle and portable electronics due to their quick startup time and high power density. Second, we have direct methanol fuel cell, that is DMFC. DMFC uses methanol as a fuel and operate at a low to moderate temperature. They are used in a portable electronic devices such as laptop batteries and small power generator. Third, we have alkaline fuel cell AFC. AFC use an alkaline electrolyte, usually potassium hydroxide, and were one of the earliest type of fuel cell used in US space program military application. They are not as commonly used today, but find application in specialized nickel area. Fourth, we have phosphoric acid fuel cell PAFC. PAFCs are phosphoric acid electrolyte and operate at moderate temperature around 150 degree to 200 degree centigrade. They are often used for combined heating and power, that is CHP application in buildings and industrial settings. Fifth, we have molten carbonate fuel cell MCFC. MCFC operates at high temperature around 600 to 650 degree centigrade and use a molten carbonate salt as an electrolyte. They are used for stationary power generation and are well suited for industrial application due to their applicability to handle impure fuel. Lastly, we have, that is the sixth one, solid oxide fuel cell SOFC. SOFC operates at a high temperature, typically around 800 to 1000 degree centigrade, and are used as a solid oxide electrolyte. They are known for their high efficiency and are oftenly used for stationary power generation and in application where waste heat can be utilized. Lastly, we have, that is the sixth one, solid oxide fuel cell SOFC. SOFC operates at high temperature, typically around 800 degree to 1000 degree centigrade, and used as a solid electrolyte. They are known for their high efficiency and are often used for stationary power generation and in the application where waste heat can be utilized. Each type of fuel cell has its advantage and disadvantage, make them suitable for different application based on the factors like temperature requirement, efficiency, and the type of fuel they can utilize. The electrochemical model of a fuel cell can be seen over here. The output voltage across the fuel cell is calculated by a Nernst potential. The equation has been shown over here. In the cell, actual voltage reduces due to presence of irreversibility. This irreversibility is due to various losses, also termed as polarization. There are three types of polarization occurs: ohmic, activation and concentration, which are specified as under. The activation polarization reflects the kinetics of reaction takes place on the anode surface. The equation for calculating the activation polarization is shown over here. Ohmic polarization. Ohmic polarization, it is due to electrical resistance to the flow of electron ion through circuit and electrolyte. In order to overcome this losses, highly conductive electrode material should be so chosen to have high electrical conductivity. If the reactant gases contains impurity, these losses get significantly increased. For calculating this losses, this relation is being used. Concentration polarization, this is due to resistance to the transport of reactant species approaching the three phase boundary, in short TPB, and the transport of product species leaving the TPB. A fuel cell performance curve is being graphically represented over here, which illustrates the relationship between the electrical output of a fuel cell and its operating condition, typical voltage and current. This curve is essential for characterizing the performance of a fuel cell under various load and helps the user to understand how it operates across various power demand. It has been seen that increasing operating temperature, the performance of fuel cell increases due to decrease in activation, ohmic and concentration losses. From this figure, we can see that fuel cell applicability, due to its efficiency, minimal emission and adaptability, fuel cell can be used in many sectors. Main fuel cell use includes transportation, automotive, hydrogen fuel cell vehicle are coming popular as a eco-friendly alternative to internal combustion engine cars. Fuel cell based vehicle have intensive range, fast refueling and no exhaust emission. Public transport, buses and commercial vehicles employ hydrogen fuel cell technology for clean, efficient urban transportation and foreign carrier. Power generation, stationary, residential fuel cell CHP system may generate electricity and heat for space heating and hot water in houses. These improve energy efficiency and lower power bill. Commercial and industrial, the data centers and the hospital employ fuel cell for power backup. They provide primary electricity for rural area and grid backup during high demand. Backup and portable power. Portable electronics fuel cell last longer than battery in computer, cell phone and camping gear. Emergency backup, fuel cell provides important system during the grid disruption, assuring the service continuity. Military and aerospace, NASA and other space organization utilizes fuel cell to power spacecraft, satellites and provide people with energy and water. Military application, fuel cell powered drones, submarine and field generator, extending the operating capabilities without refueling. Handling material, industrial fuel cell forklift and warehouses equipment have longer operational period, faster refueling and lower emission than lead acid battery powered equipment replaced by this fuel cell. Off-road and maritime vehicle, fuel cell are being investigated for clean propulsion in ships, ferries, tractors and construction equipment. Grid store energy, power to gas, power to power, hydrogen based energy storage technology are being developed to stabilize the grid and store excess renewable energy, remote and offline power, fuel produce dependably energy in remote weather station, telecommunication towers and isolated village. Without sustainable infrastructure, fuel cell technology is being researched to improve efficiency, low price and broaden its use in numerous sectors. From this figure, we can see the fuel cell power spectrum. The fuel cell power spectrum, fuel cell refers the range of power output that a fuel cell can deliver under various operating condition and configuration. The power spectrum of a fuel cell can vary significantly depending on various sectors, including the type of fuel cell, its design, size and specific application it is used for. Here some key points related to power spectrum of fuel cell I am going to show. First, the type of fuel cell. Different types of fuel cell such as proton exchange membrane, PMFC, solid oxide fuel cell, SOFC, alkaline fuel cell, molten carbonate fuel cell have varying power spectrum. Some may be better suited for high power application, while other excels in low or high efficiency application. Second, we have operating condition. This power output of a fuel cell is influenced by operating condition, including temperature, pressure and concentration of reactants, that is hydrogen and oxygen. Adjusting this condition can impact the power output and efficiency of the fuel cell. Third, we have the size and configuration. The physical size and configuration of fuel cell stack plays a role in its power spectrum. Smaller fuel cell may be limited to their power output compared to larger systems. Fourth, we have load requirement. The power spectrum of a fuel cell must match the power requirement of the devices or system it is intended to power. Fuel cell system can be designed to meet a wide range of power demand, from small electronic devices to large vehicle and stationary power generation. Fifth, we have efficiency. Fuel cell are known for their high efficiency, especially in converting chemical energy into electricity. The power spectrum often includes a range of power output while maintaining high level of efficiency. Sixth, we have transient response. Fuel cell can have varying transient response, which refers to their ability to respond quickly to change in power demand. Some fuel cell may have faster transient response suitable for application like electric vehicle, while others may be better for steady state power generation. Seventh, we have hybrid system. In some application, fuel cell are used in hybrid configuration with other power source such as battery or supercapacitor. This allows for a broadened power spectrum and improve the system performance. Eighth, we have the scalability. The power spectrum of a fuel cell can be extended to stacking multiple cells in series and parallel, enabling the scalability to meet the power requirement of different application. Sixth, the durability and reliability. The power spectrum should consider the durability and reliability of the fuel cell under various operating conditions and over its lifespan. Thank you.